polynomials of a higher degree. To start out, we're going to look at some examples here of transforming them. So let's start with Ali. Ali, tell me on this one, what will that 4 do, or what will that plus 1, how will it change our parent function? Any guesses? If it was a quadratic, it'll be last time we looked at quadratics, and the transformations are actually just the same.
So it either go from sideways or it'll just change the x.
How so?
Well, if the plus one was different, then we go left one.
Okay.
So it's where the x.
Good job. So this is going to shift it to the left one. You're spot on right there. Let's see. No, I don't think it's going to let me right here. Ooh. Let's use the whole thing. Never mind. We don't want that. Let's see if I can do it here. So we're going to say that this makes it go left one. Okay? What about that timesing by 4? What is that going to do to it? I'll just say that to everyone. Yeah, it's going to, what's the word we're going to use here? Stretch it out. There we go. This is what we call a vertical stretch. Now, here's what I want you to do. I'm sorry, I'm writing with my finger, so it's not looking very good. But I want you to go into Desmos, okay? And what I want you to do is graph x cubed. That's your parent function here. So everyone start off graphing x cubed. You're going to, so good question, how do you do a cube? So you're going to put x, and then you're going to push the caret button, and then put in a 3. I think that caret button, what is that about? 6, so shift 6. Okay, does everyone have x cubed? What shape did that make? Maybe show me with your hands once you got it. What shape does that make? Awesome. I'm going to put this down so I can show you. So I call this the S curve. Okay? So story, I'm going to tell a lot of stories in this class. Last June I was playing soccer and a goalie came out and he broke my leg. Not a fun story. So I had to go get surgery, and guess what? The scar looks like from the surgery. That's an S curve, right? So now I've got that like tattooed on my body with the scar. But anyway, so math, there we go. So I've got this on my leg. Maybe one of these days I'll show you when I'm wearing shorts. Okay, now what I want you to do is I want you to put in this. Go to the equation right below it and put a 4 and then parentheses x plus 1, raise it to the 3rd. And let's see, did this shift it 1 to the left? Did it stretch it by a factor of 4? And if you do the one right under it, it should graph both of them. All right, what do you guys think? Did that work? Okay, so now I'm going to have you do kind of the same thing here. I want you to put in x to the 4th. We'll talk about the transformations, and then we'll do the equation. Are you doing the next one? You need help, let me know. So right now, everyone, you're graphing x to the 4th. Okay, Joshua Wood. That's you, right? What shape does x to the 4th make?
Kind of x to the 4th or the 3?
Just the x to the 4th when you do the parent function.
Oh.
So you just kind of like a quadratic, right? But it's just a little skinnier, okay? So x to the 4th makes this U shape. Now, don't graph this yet, but when I graph this modified, what are the modifications going to be? Let's go through. There's 3 things on there. Let's see if you can tell me one of them is. So let's go to Mikhail. Oh, Mikhail's not here. Arlette, Tell me one of them.
For what?
Here's your transformations. What are they going to do when we graph it? What would a negative do to it? Not this way. Nope, not that. Well, we are going to see that, but it's not because of the negative. If I have a negative x squared, what does it do to my u? It's going to flip it. So that negative, this is actually going to flip it over the x-axis. Now, you said it would go left or right, and that's true. How much is it going left or right? 2, and in which way? When we see the negative, we want to think left, but what do we remember with the parentheses? Do the opposite. So this is actually going to go to the right 2. And lastly, what does that plus 5 do, guys? That moves it up 5. So what I want you to do is on the first graph for Desmos, I want you to do plain old x to the 4th. It should give you a U shape, kind of like the quadratic, but tighter. Then I want you to type in this one and see, hey, did that flip it? Did it move it to the right 2? Did it move it up 5? And then if you've got it, check with your neighbor to see if they got the same thing. Let's see if we're on the same page. So, if you want you to go over so you're kind of like isolated here. So that way you have something to check. Does that look right? We flip, we went left 2 up 5, looks good. Alright, were you guys able to get that in there? Isn't Desmos neat? Alright, so now what we're going to do is we're going to keep talking about these cubic and these quartics. So let's just clarify right here. When your degree is 3, we call that a cubic. When your degree is 4, we call that a quartic. Quartic. Alright, let's keep on rolling here. So we're going to do a lot of practice using Desmos or using the graphing calculator, because when we're getting to these, we're not used to seeing these as much. So the Desmos can be our friend in helping us out here, okay? Alright, so let's look at this. Graph the polynomial function, locate its extrema and zeros, and explain how it is related to the monomials from which it was built. Okay, lots of stuff going on in there. Let's break it down. When it says it's extrema, does anyone know what that means? That's alright. Extrema just means where are the maximum points, where are the minimum points. So our graphs are going to have little hills and valleys, and we want to say where are the tops of the hills and where are the bottoms of the hills. Then we say zeros. Zeros is just another way of saying, anyone know? Intercepts, good job. In particular, your x-intercepts. But we also want to look at your y-intercepts. And then lastly, it says explain how it is related to the monomials from which it was built. In other words, it's saying let's compare it to the parent function. So our parent functions are just our very basic graphs. And then we're going to compare it to the ones that are transformed. So in this case, we're going to look at x cubed. What shape that's our parent function here, right? Do you see how x cubed is the highest exponent, so our degree is 3. So the general shape this is going to take on is x cubed, what does that look like? Show me with your hands. X cubed is, which one? It's hard for me to do it on this, but it makes that S curve, right? Now what you're going to do is on Desmos, you're going to do x cubed plus x. And let's see, how does adding that x change the shape? I'm going to kind of walk around and you guys Alright, so I want you to turn to your neighbor. How is x cubed different than x cubed plus x? Alright, let's go to Adam. Where you at, Adam? There's Adam. So here's x cubed I just graphed it. Some of our key points here. So let's talk about the parent function for a second. We're talking about x cubed. Let's plug in some points. What does it mean to cube something? If I square it, what does that mean? Times it by itself. So what would cube mean? There you go. So I'm going to start plugging in numbers here. Let's do 0. 0 times 0 times 0 is? Good job, class. What's 1 times 1 times 1? What's 2 times 2 times 2? 8. Okay, and then we go 3 times 3 times 3, 4 times 4 times 4. This is how we get the graph of x cubed. Now, Adam, how was x cubed plus x different than just plain old regular x cubed? So this isn't perfect, but it's basically going to be kind of like that. X cubed plus x. So it made it a little bit tighter. Great. Now, did we have any maximum points or minimum points? Were there any hills or valleys on this? Well, we kind of got this point right here, but that doesn't count. We call that an inflection point, but that's going to be different. Adam, what about zeros? Did we have any zeros here? We had one x-intercept. Where was that x-intercept at? Just at 0. We crossed the x-axis at 0. So that's our x-intercept and our y-intercept is 0. Okay, but really nothing too exciting on this one, right? Well, let's go to the next one and see if maybe we can get something a little more exciting on that one. Go to the next page with me here. How is this one different? Instead of plus x, it's minus x. Well, let's just do the same thing we did before. Let's start with our parent function x cubed. By the way, what's a negative times a negative times a negative? Is that going to be a positive or a negative? Negative. That's why over on this left side it's still negative because it's cubed. Here's our parent function. I want you to graph it on Desmos. How is it different? Doesn't this one look more fun? Alright, so Micah, how is this one different when we do x cubed minus x?
The hills go higher and lower.
There we go. We kind of have, instead of just this plain old like this, I think we have like a hill here and then a valley there and then we go up, right? Now, does your computer show you where the top is? Like if you zoom in on it, will it show you the coordinates for the hills and valleys? Awesome. Okay, so what is the coordinates for the hill, the top of the hill? Okay, so like negative 1/2-ish. And what was the y? 0.3, so kind of like right here. Alright, and then what about for the bottom one? Was it just the negatives of that? Alright, so that, wait. Okay, now what were the x-intercepts on that? 1, what else? Negative 1, and there's one more. 0, so when I graph this, it's going to come up to negative 1, then go to that hill, go through 0, go to that valley, and go like that. And my graph's not beautiful, but is that kind of like what Desmos looks like? Alright, so when we're going to look at this, let's let's look at we said that there is a local, we call it a local minimum, that's this bottom point here. And I believe you told me that was at about like 0.5 and negative 0.3-ish, right? It's kind of decimals, but is that about it? What was that?
It's closer to 0.4.
Is it closer to 0.4? Okay. I'll just change it like that. We had a local maximum point that was at negative 0.5 and a positive 0.4. And Angelina, what were our x-intercepts here? And then one more.
0.
There you go. And if 0 is an x-intercept, then that means 0 is also a y-intercept. All right. Now let's talk about this real quick. What if you didn't have a graphing calculator? Do you have any idea how you'd get to graphing this? Do you remember using XY tables? Where you'd say, okay, I want to plug in points like negative 1, 0, 1. Plug it in and see what happens. Yeah, but fortunately we've got decimals, so that should be a little easier. Okay, let's keep on rolling here, guys. What we're going to do now is talk about end behavior, okay? And that's just basically a fancy way of saying shape. Here's what I'm going to do. There are, I think, 12 graphs here, okay? And what you're going to do is you're going to just give me a quick basic graph. So what you're going to do, for example, everyone on number 1, I want you to type in 2x cubed. And once you do that, put your hands in the air. What does it look like? Show me what 2x cubed looks like. And it should be just a basic S-curve. So you're just going to graph like that. Then you're going to go to negative x cubed. And I want you to just do quick graphs. Make them quick. Don't worry about the axes. Don't worry about scales or key points. Just give me a general shape of what it looks like. We're going to do that for 12 months. So go ahead and do that and check your work with your neighbor. Also, while you're doing that, look for patterns. And if you get stuck or need help, please call me over or ask a neighbor. Now, if your computer's getting too crowded, is it okay if you go back and delete some of them? Yeah, for sure. You don't have to have them all on there at the same time. It gets a little crazy. If you need to delete some, that is just fine. So give you about another minute, and then we're just going to go through, and you guys are going to show me real quick what those will look like. Awesome. And if you're done, check your work. You got about another 30 seconds. Alright, here's what we're going to do. We're going to start in the back with Joshua. And we're going to kind of work our way, snake up through here. You're just going to show me with your hands what it looks like. So I already did number 1. 2x cubed makes this kind of S curve like that. So Josh, for part B there, what would negative x cubed look like? Yeah, it just got flipped over, so now it's going to look like that. Is that what you were drawing for me? Great. Arlette, what about x to the 5th? Okay, so it's, you were saying it's more, so I'm not going to draw perfect, but kind of that shape still, right? So kind of like x cubed, but it's just still x to the 5th. Okay, great. And then let's go back, I believe, is it Beyonce? Yes. Okay, how would I do that one? Same thing but flipped, so it looks like that. You guys agree so far? Great, now I'm going to teach you what's called end behavior. We're going to describe what's going on here. And we're going to start out using very imprecise, we're going to just use really easy way of saying it. What we're going to do is read this left to right, and you're going to tell me what direction is it going. This is going down, up. Because on the left, it's going down, and on the right, it's going up. So I'd write that as down, up. So then how would we describe the next one? Down, because on the left it's going up, on the right it's going down. Pretty easy, right? So then how would I write C? It's down, up. And D. That's up, down. Okay, good job. Our football players know all about up, downs, right? Okay, let's go to number 2. Where did we get to? I want to say Magdalena. With an or just Magdalene? Just Magdalene. Okay, Magdalene. What's a graph of 2 look like? Like this. How would we write that? What is that? How on the other one we're doing down, up, or up, down? How would we describe that one? Down, down. Good job. It's going down on the left. It's going down on the right. Could also describe that as Kesha. She's going down. All right, okay, keep going. Mabu. What about B? What would that look like? So it's a U shape. He's making a little U shape there.